Hi everyone, and welcome to our video on approximating areas by using Riemann sums. So I left it here where our last video left off here where we found the approximation of an area under a curve using rectangles. Well, Riemann sums is this using the approximations with rectangles. All I did though is it's written out real formal here. There's three different ways that we can look at Riemann sums. So in these problems we did the midpoint, using the midpoint for each rectangle to help us. Well, you could also use the left one. So like in this picture, it shows, I'm going to put a big dot on it. So it's using the most left point of the rectangle that hits the curve to help. Here's the right, which is using the rightmost point of a rectangle to help us out. And then the midpoint is what we did in the last one, which is using the midpoint of the rectangle that hits the curve to help us out. So this y equals f of x is telling you the height of the rectangles. Okay, and then we have all these different little these little symbols. I thought I'd put that in there just in case you wanted to look over it to see how formal it is with the math. But all we really want to do is, so a Riemann sum is approximating an area, and our area is based on the base of a rectangle times the heights of each of the, let's just say the sum of heights of all rectangles. Of all rectangles that we use. Okay, and one of the ways that we might say that, let's do it again. So the area equals, let's use the word base one more time. So the base, the sum of the heights of all the rectangles that are used. So they might use like height 1 plus height 2 plus height 3, however many they want us to use. I'm going to use dot 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 plus height with a little n. So how the n is the number of rectangles they usually want us to use. Okay, so it looks a little strange, but h n. So if they said use 7 rectangles, we would go 1, 2, 3, 4, 5, 6, all the way to 7 heights. Okay, and what they also usually do for the base, so one more time, the area, the base, let's put that over here actually, the base is often set to be equal to delta x. So the delta means the change in x. So what they mean by this is just x could change depending on the number of rectangles that are used. However, it's still, once we figure it out in the problem, it will stay the same number. So we're going to write delta x here, and then again h1 plus h2 plus h3 plus dot dot dot, however many, plus h little n to however many rectangles they want us to find. Okay, and then the delta x, though, one last thing, one more part of this formula. The delta x is equal to b minus a over n. So the b is where, I'm going to just circle it on this first one. So there's b, and then there's a. So a is where they want the graph to start for our first rectangle. B is where it wants it to end. So we'll subtract those two to get the full length. So b minus a is the length from B to A, the horizontal length, and then just divide by the number of rectangles. So the n still represents the number of rectangles. Okay, so let's put this to practice. So we're going to approximate the area under the graph of f of x and above the x-axis with rectangles using the following methods with n equals 4. Okay, so we've got f of x equals, here's our function, from x equals 2 to x equals 6, using the left endpoints, right endpoints. We'll average it, and then we'll also do the midpoints. Okay, so often these problems are kind of usually long. All right, so what I'm going to do first, let's get our graph. So I'm going to use Desmos, and I'm just going to get that graph in there. So we have x squared plus 1. Okay, so that is our graph, and they said from x equals 2 to x equals 6. So maybe let's zoom out a little bit, and what I want is I want the points here, so it might be best at this point. I'm going to get a table. Okay, so I can see the graph. Let's get 2 so far and 6 so I can see those points. And then let me go ahead and just delete these other ones. because I don't want them right now. So we'll come back to this table. Okay, so I could see those points. Maybe let me zoom out a little further. Okay, so 6 is pretty high up there. Okay, so there it all is. So that's our graph with those 2 points. So what I want to do, I'm going to kind of copy this, but maybe not to this scale. So let's change this. So the x-axis, let's go from 0 to 7, like that. And then from there, that way now I'm zoomed in on my points that were important to me. Okay, so I looked at the whole, so we had a whole parabola, and we can still zoom in and zoom out. So I have a parabola shape. It's just now the scale, the x-axis is really stretched out. Okay, so that we could see it a little better. Okay, anyway, so let's use that sketch there. So we always want to sketch these out. So whenever they tell you to approximate, well, let's go ahead and get a sketch. So in this first one, and I'm not going to draw the whole thing. It looks something like this. Okay, and I have the point there that was important to me, and the point there that was important to me. This was at 2, and then this was at 6. And so all I'm going to do is put this in like that. Okay, so that's our starting point. That's our ending point, just right there. Okay, and all I want to do is now I want 4 rectangles on here. Okay, so to get 4 rectangles, well, first thing I want to do is let's go ahead and find the base. Okay, so let's get the base also, which is our delta x, which is the b minus a over n. Okay, so in this problem, we have our b is really 6. So they said from x equals 2 to x equals 6. This is really b, so b is 6. And then that x is really a. And so we could plug those in, and we have 6 minus 2 over the n. They told us n is 4 right there. So we'd have 4 over 4, which gives us 1. Okay, so what I want to do now is every one length I want to label on my x-axis. So from 2 to 3 to 4 to 5 to 6. Okay, and then that's where I'm going to start to draw in my rectangles. Now, it says to use our left endpoints. So that means starting at the 2, I drew a rectangle until I hit this dot. And then now I'm just going to draw the horizontal part of the rectangle until I get to about where the red dot would be, where I can make the vertical. Just like that. And then now with my second dot there, so let me go ahead and label this was 3, 4, 5, and 6. And we know each of these has a length of 1. So those are the base of each rectangle, 1, 1, 1, 1, 1. Okay, and then I want to just keep doing the same thing. So at 3, draw up all the way until you hit the curve, and then draw a little right until you're about at 4 on the x, and then draw it down. And then we'll repeat, draw up on 4 until you hit the curve, and then we'll get our other rectangle part going, the little horizontal, and then down to 5. And then one more time, all the way up to the curve, and then we'll make our rectangle like that. Okay, so what we just did is we set up our rectangles, and then what I really want is the heights of each of these rectangles. Okay, so and to get those heights, well, again, that's where the calculator is super useful for us. All right, so I've got this table. Well, what I'm going to do, so let's put it in order. So 2's good. Let's get 3 now. 4, 5, and the 6. Okay, so there's all of those points, and we graphed them the same way, just it doesn't show the rectangles as nice on this graph as it did on my paper. However, it does tell you what those points are, and really these y coordinates are the heights. Okay, so we've got the heights of all of them right there. Okay, so we have 2, 5. Let's go ahead and copy those. Okay, so at this point I have 2, 5. Might be a little tough on this short distance. And then at 3 was at 10 using that calculator. 3, 10. Yeah, this might be a little too tough. Let's do a different strategy. Okay, so I'm going to put this over here. So I'm going to copy that table. So this is our x, this is our y, which again represents heights of our rectangles. And so when I plugged in 2, 3, 4, 5, and 6, so those were my 5 points that I have plotted here. We had our height was 5, 10, 17, 26, and 37. Okay, so now we've got all these heights. The ones that are important to me in this scenario are based on these. Let's go ahead and make these dots bigger. So I have one height there, I have one height there, I have one height there, and I have one height there. So I should have 4 heights because of 4 rectangles. Well, my first height started at x equals 2, so I want this one. This would be height 1. This one here is going to be height 2 then. This one is height 3, and this one is height 4 for this left endpoint problem. Okay, so now, all of this to the side is eventually leading us to this area, and I'm just going to use capital A for area. And all it is, again, is the base, I'm going to write it in words again, times the heights of each rectangle. So I'm going to use h1 plus h2 plus h3 plus h4. And then now let's plug those in. Okay, so I use the base. The base is just 1 in this problem. And then our heights, well, I have them labeled there, 5, 10, 17. So 5 plus 10 plus 17 plus 26. And then from here we can add them up. So I have 1 times 5 plus 10 plus 17 plus 26 is, so 15, 32, 58. So we have 58. And then so now we have it all the way done. The answer is 58. Okay, so that's our approximation using these left rectangles to show the area under the curve. Okay, here's what's kind of good about these problems. So no matter what, they are long. But our right endpoint kind of starts off in a similar way. Let's set up our equation. It is the area equals the base times the heights of 4 rectangles. However, I have to make the adjustment on the heights. Okay, so I'm going to copy that picture right here for this problem best I can. And we have 2, 3, 4, 5, and 6. This time around, though, so with right, I think start on the right. Start at your end value on your x-axis. So we start at 6, and I'm going to draw that up until I hit the curve. And then after that, I'm going to draw my rectangle to the left to where 5 is. And then let's draw it down. And then let's do the same thing at 5. Draw it all the way up. And then go left until you're at 4. And then draw your rectangle down until it hits 4. And then at 4, do the same thing at 4. Draw and then horizontal down to 3. And then at 3, horizontal till I get to 2. So notice on this problem, our rectangles are above the curve. So this is an overestimate. Our first one, none of the rectangles went above the curve, so this is an underestimate. Okay, so one of them, so this is a little short of the actual area. This answer, when we get it, will be a little bit bigger than what it should be. Okay, but let's figure this one out. So we have the base is still the same. The base is no matter what 1. So it's 1 still. Our heights are different though. Okay, so those heights, so we can use this table one more time. The heights for the right endpoint, so I'm going to label these here. These are our left endpoints. What I want to do is the right. Well, the right, notice I don't start at 2, but I start at 3. And then I have 4, 5, and 6. Those are my x coordinates that help me get the height. So I really want to start at 3 here. So this 10 would be my height 1. And then the 17 is height 2. The 26 is the height 3. And then the 37 is the height 4. Okay, so it's like they all just shifted down 1. And so now I can add all those up. 10 plus 17 plus 26 plus 37. Okay, so that's our difference there. So notice it kind of carries the same data over. And once you get comfortable, you might not even need these types of pictures. You could kind of jump to it. Okay, but let's go ahead and do that addition. So it's the 1 is still just 1. And then we have 27 plus 26 is 53. And then that adds up to be 90. Okay, so we have 27 plus 37. Yes, that is 90. Unless, hopefully I did the arithmetic right. Okay, so everything's good there. And then once we multiply these, so the area is 90. Okay, so but we knew that this one is an underestimate because we said the rectangles, we can see the gaps under the curve. So this is an underestimate. This one, we see the rectangle goes over the curve, so we have too much area. Overestimate. So they often might average these answers together to get a more accurate answer. So if we average them, that is just add those two that we just had and then divide by 2. Okay, and when we do that, well, it looks like it'd be 148 divided by 2, which gives us 74. Okay, so 74 probably is the closest answer for our area under the curve. But let's do one other scenario. Let's also use the midpoints, and we will be, so eventually all this leads to, like in our previous video, let me scroll a lot. In our previous video, we talked about the runner. Okay, so what eventually we will have, we will have more accurate ways, but like in most things in math, we usually take our time to get there. So we do it the hard way first, like what the pioneers of math did. So they struggled and figured things out. So we're kind of walking the same path they did. Okay, but anyway, let's do the midpoints. So the midpoints, it's still, let's go ahead and set up our formula. It's still the base times the 4 heights, but now the heights again are different. So the heights change depending on our scenario. So our base is still 1, but then our heights, I'm going to leave that just blank for now. We're going to come back. Well, one more time, I have this graph. Let me go ahead and draw it. Okay, so it's something like this, and we started at 2, 3, 4, 5, and we ended at 6. Well, this time around, and I know the base is already 1, so that's these numbers were nice to us. So I know we want to go at the midpoint until we hit the curve, and then from there, draw that rectangle in. And then do it again from 3 to 4. So, and then draw that rectangle in, and then in between 4 and 5. So right in between those, like that. And then one more time in between 5 and 6, like that. Okay, and so what's important for us in this one, let's do green. Well, the midpoint is using 2.5, 3.5, 4.5, and then 5.5. So these are the x values that will help us. So this first table I was able to use twice in the 2 different scenarios. Well, I'm going to go ahead and just state, well, let's get a different table, and let's use the 2.5, 3.5, 4.5, and 5.5 x values, which will give us the heights to 4 new rectangles that lets us find the area. Okay, so I'm back to here, but what I'm going to do is let's change these. Okay, so 2.5, 3.5, 4.5, 5.5. And then all the others I don't really need. So I'm going to delete them at this point so I'm not confused. But there they are. So 7.25, 13.25. So we're just going to write those in. 7.25, 13.25, 21.25, and one more, 31.25. So these are the heights I want to use for this problem. So let me do green here. And our heights, when we plug them in, so we have 7.25 plus 13.25 plus 21.25 plus 31.25. And then now is where I'm just going to use the arithmetic, the calculator. I'm just gonna use this basic one. So we have 7.25 plus 13.25 plus 21.25 plus 31.25. And we get 73 times 1, which would be 73. Okay, so we have the area here is 73. Okay, so there we go. So there's all of the different answers that we got for this problem. Now, they're all just approximations. If we want them to be more accurate, we would use more rectangles to help us. But other than that, that's it. Okay, so, and again, what we're going to do is eventually lead to a more accurate way, but we're just doing it the long way for now. Okay, so we'll take a pause. We'll come back and do some other scenarios. But that's it. So thanks for watching, and I will see you again next time.